In this next group, we're going to continue to do the same. We're going to try to get the absolute value by itself. Then both the positive version and the negative version will have whatever's in the absolute value staying the same. Then the other side will have its positive and negative version. Remember, the positive version will stay the same, and the negative version, where you flip the sign of the number, and you'll actually flip the direction the inequality is pointing. So you'll do those two things all over again. And let's see what happens. So let's start with problem A. In problem A, we have the absolute value of 2x plus 1/3 plus 1 is greater than 4. So we'll start by getting the absolute value by itself, which the problem is the absolute value isn't by itself because there's this plus 1 that's dangling off to its right. So we're going to move that or get rid of that by subtracting a 1 from both sides. So let's see what happens. Well, that will get us the absolute value of 2x plus 1/3 is now greater than a positive 3. But at least the absolute value is by itself on one side and our positive value is on the other side. That's what we wanted. So let's look at our positive version of our inequality first, where everything should stay the same. So remember, what's inside of the absolute value always stays the same. That's at 2x plus 1/3. And we'll keep our 3 as a positive 3 and keep the direction of our inequality as well. Let's take a look at our negative version of our inequality as well, which again, whatever inside the absolute value will stay the same. So we've got a 2x plus 1/3. We'll have a negative 3 in the negative version, and instead of the inequality being a greater than, it's going to flip direction and become a less than in our negative version. So we switch the signs, and we flip the direction of the inequality. Then we've got two inequalities that we can solve that are much smaller and much easier to deal with. So let's take a look. So in the first one, let's see. Next, what we'll do is solve our equations. If you're one of those people who hates fractions, you can get rid of all your fractions by multiplying everything on both sides by 3, because that's the denominator. And what'll happen is we'll multiply the first piece by 3, which will get us a 6x. Multiplying the second piece by 3 will actually cancel out the 3 and leave you with a plus 1. The inequality won't change. That's still a greater than. However, don't forget that you multiplied the other side by 3 as well, which will get you a 9. Let's see. Now, continuing along, we would just solve this like a regular inequality by subtracting 1 from both sides, which will get us, let's see, this will get us a 6x is now greater than 8. Then we'll divide both sides by 6. And continuing along, what that does is that gets rid of our 6 and gives us x is now greater than 8/6, which does reduce. Both are divisible by 2, so it will reduce to x is greater than 4/3. So that's part of our inequality and part of our graph. Okay. Continuing along, let's work on our negative version. Our negative version, we need to start off very similar. We can start off by multiplying everything through by 3. That will still give us the same idea. Will give us a, 6x. Canceling out the 3's will give us a plus 1. Is less than. Don't forget you multiplied by the other side by 3 as well, negative 9. Continue solving normally. We will go ahead and subtract 1 from both sides, which will give us, a 6x is now less than negative 10. Dividing both sides by 6. Gets us x is now less than negative 10/6. Again, this fraction can be reduced. They're both divisible by 2, so it'll reduce to a negative 5 thirds. So we're going to have two numbers on our number line. This one from this inequality is a negative 5 thirds, and the one from the other inequality was a positive 4 thirds. Now let's draw it out and see what's going on. So for the first inequality, the x is greater than 4 thirds. Notice our inequality is pointing to the right, and the x comes first, so our graph will also point to the right. There's no equal to, so we'll be using parentheses, not brackets. Our second inequality we're getting is that x is less than negative 5 thirds. Again, it's pointing to the left, and the x comes first, so we can use our little trick that it will also point left. There's no equal to, so again, we got to use parentheses, not brackets. However, notice that this time we're getting an interval notation that has two pieces. So this first piece, reading it from left to right, would start out with negative infinity up to negative 5 thirds. Remember, there's a parentheses at negative 5 thirds because there's one on our graph because we didn't have an equal to. Negative infinity, though, no matter what, will always have a parentheses. Now, continuing to left to right, we need to do our other last-minute piece, which starts at 4 thirds with a parentheses because we had no equal to. And then the arrow means it continues on to forever towards infinity, which also always has to have a parentheses because it's an infinity. Now we have two pieces. We have to put them together with a U or a union symbol, but that is our final answer for this one, and we're all done. Let's take a look at B. In problem B, we've got 4 times the absolute value of x minus 3 minus 1 is greater than or equal to 11. So the first thing that we would want to do is get our absolute value by itself. We need to get rid of that minus 1 that's dangling, so we'll add 1 to both sides. We're still not quite where we want to be because we still have 4 times the absolute value of x minus 3 is now greater than or equal to, well, 11 plus 1 will give us 12. The reason why we're still not quite done is this 4 that's out in front of our absolute value. It's still outside of the absolute value. Now, it's currently being multiplied by the 4, so to get rid of it, we'll divide both sides by the 4. That will move the 4 over from one side to the other. Now we'll finally have the absolute value of x minus 3 by itself. It'll now be greater than or equal to, well, 12 divided by 4 will give us 3. Now that the absolute value is by itself on one side, and our positive value is on the other side, we can break it down into our positive version and our negative version. Remember, our positive version is going to stay the same. It'll be x minus 3 is greater than or equal to 3. You just basically drop the absolute value sign. However, when we do our negative version, you still have a part that's going to stay the same. That's what's inside of your absolute value. The x minus 3 will stay the same. Our number on the other side, though, will become negative 3. And remember, when we start throwing around negatives, we flip the direction of the inequality, so it'll be less than or equal to now. Remember, we're switching the signs and flipping the direction of the inequality. So let's go ahead and solve these. So this first one, we'll add 3 to both sides, which will get us, let's see, x is greater than or equal to 6. On the second one, we'll still add 3 to both sides. And let's see what that gets us. That will get us x is less than or equal to, well, negative 3 plus 3 is 0. So we'll have two values once again, 0 and 6. So let's put those on our number line. We've got 0 and 6. Let's graph these one at a time. Let's start out with the 0. X is less than or equal to 0. Well, remember the inequality is pointing to the left, and the x comes first, so our graph points to the left. Notice there's an equal to, so we will be using a bracket this time. With the second inequality, we've got an x is greater than or equal to 6. And again, the inequality is pointing to the right, and the x comes first, so our graph will also point to the right. The equal to means, again, we're going to use a bracket. So, reading our graph from left to right, we'd have to start out with our first piece on the left, which starts out going towards negative infinity. So we'll start out with a negative infinity all the way up to 0. Notice 0 has a bracket. Negative infinity always has to have a parentheses though. Continue reading left to right, we pick up with the second graph, which starts at 6 with a bracket. And the arrow means it continues on forever towards infinity. That's a positive infinity. Again, infinities always use parentheses. And we got to put these two pieces together with a union symbol so we can unite them together. Let's take a look at a few more. Let's take a look.